All right, I'm talking some more about multiplying radical expressions, and I'm going to focus on especially binomial expressions. So with this, if I've got two binomials with radicals in them, so say I've got something like the square root of x minus the square root of 3, and let's multiply this by like square root of 3x, and then say plus a square root of 2. Whenever we're doing this, you're going to do like you normally would. You would FOIL your expression, and then you're going to simplify each radical. So you're going to FOIL. So let's do that. Square root of x times the square root of 3x. This is going to be the square root of 3x squared. Square root of x times square root of 2 is going to be plus square root of 2x. My inside term, I've got negative square root of 3 times the square root of 3x. It's going to be minus square root of 9x. And then our last one, this is going to be minus the square root of 6. And now we can go ahead and simplify these. And if I want to, I could break this up into 2. I hope it's fairly easy to see that this square root of x squared, this is, thinking about this, this is a square root of x squared times the square root of 3. This is just going to be x square roots of 3 plus my 2 square roots of x. This is going to be minus 3 square roots of x. Oh, hey, whoops, wait a minute. I made a mistake. That's not minus 2 square roots of x, that's minus square root of 2x. Can't put those together. And then minus the square root of 6. And taking a look at this, I don't have any like terms. I've got a square root of 3, and none of these, I've got none of the rest of these are square roots of 3. I've got a square root of 2x and a square root of x, but those aren't like radicands either. And I've got a square root of 6. So we're done right here. A reminder also that if you have something like say we had like the square root of 3 plus the square root of 5, if I've got some other coefficient here, this gets multiplied, this would only multiply other coefficients. So when I FOILed this, this is going to be 4 square roots of 9. Notice I'm just multiplying the radicands, but that coefficient stays outside. Now this is going to be minus the square root of 15, and this is going to be plus 4 square roots of 15. And then when we end this, I've got minus the square root of 25. So I can put together my like radicals here, and I wouldn't be able to simplify these. So I'm going to do that. The funny thing is I'm going to do this first. It'll be 3 square roots of 15. This right here, this is going to be 4 times 3, and this is going to be minus 5. So I'll have 12 plus 3 square roots of 15 minus 5, and here I'm going to end up with 12 minus 5 is 7. Those are 3 square roots of 15. So this stuff tends to look more intimidating than it really is. One thing I definitely want to talk about, though, is let's talk about a couple of our special forms. And our special forms are things like the square of a binomial. So if we are squaring a binomial with radicals, we can, in fact, use a shortcut, but I don't think it's going to be much of a shortcut for most folks. Remember, anytime I've got anything squared, this actually means I've got oops, not like this. This is going to be a plus b times a plus b. So we're still going to need to FOIL. So for example, say we've got something like, oh, I don't know, 3 square roots of x minus 2 square roots of y, and I square this. Looking at this, we're going to have a little bit of work to do. I'm going to have 3 square roots of x minus 2 square roots of y, and we could in fact use a shortcut that we would use for some of these, but I think for most folks, just taking the long route for this is going to be a little bit easier. 3 times 3 is 9, and that'll be the square root of x squared. I'm going to have minus 3 times 2 is 6 square roots of xy, and then again, I'm going to have another minus 6 square roots of xy. Rather than apply the model, I think it's helpful to see where all of these are coming from. We've got enough going on. Negative 2 times negative 2 is a positive 4, and the square root of y times square root of y is square root of y squared. Again, I'm going to add together my middle two terms, so this is going to be minus 12 square roots of xy. And when I simplify each of these, this is going to be 3x minus this 12 square roots of xy, and then plus 4y. Nothing else combines, so we're done right here. So when you're squaring a binomial with radicals, I find it's easiest to just make sure you've got both of these written out and FOIL your answers. But now let's talk about something where it is going to be easier to use the model. And that is our conjugates. And especially when it comes to radicals, I think you're going to see why it's helpful. Because if I've got square roots, it's very helpful if I could just square those. And I'll show you the long way and I'll show you the short way with this. So here's our long way. Let's say we've got, well, let's do that same one that we did before. Let's do 3 square roots of x minus 2 square roots of y. And I'll just multiply that by 3 square roots of x plus 2 square roots of y. Oops, I ran myself out of space. Okay, this is going to be 9 square roots of x squared plus 6 square roots of xy minus 6 square roots of xy, and then minus 4 square roots of y squared. And hey, yeah, those are going to cancel out when I add those together. And I've just got 9x minus 4y. The short way is just saying, oh, what happens when I square each of these terms? This is the shortcut. I've got less thinking to do. It's just a matter of recognizing that one of these is positive, one of those is negative, and it's the same terms. So 3 square roots of x minus 2 square roots of y, and 3 square roots of x plus 2 square roots of y. It's literally just saying this squared minus this squared. So, oops, sorry, that's 3 squared square roots of x squared minus 2 squared roots of y squared. Oh, that's going to be 9x minus 4y. In a lot of ways, that's going to be the easiest way of doing it. And when you get fast at this, you start to realize how cool is it to be able to just do something like this. Oh, it's square root of 3 minus the square root of 2 and plus. That's going to end up being square root of 3 minus that square root of 2. 3 minus 2. This whole thing comes out to be 1. All righty, that's all I've got for now, and I will see you in the next video.